Here, question is, calculate the H11 for the circuit shown below. Here, the definition for the hybrid parameter H11 is nothing but V1 by I1 and V2 equals to 0. That means input impedance we have to calculate. But see, input side it is short circuited, means V1 is nothing but a 0, hence H11 is 0. Hence option A is correct. Here the question is, a network having 4 branches and 2 nodes. Calculate the number of fundamental cut sets possible. We know that this is a question from the graph theory where number of fundamental cut sets equals to the number of nodes minus 1. Here the number of nodes are n. Here n is nothing but a 2 here. So 2 minus 1 is 1. Hence option C is correct. Question is, calculate the Thevenin's resistance seen by the terminals A and B. That means we have to calculate the impedance of the network when we are looking from the input side. That is, if we consider this one is I1, then the input impedance is nothing but, or Thevenin's impedance is nothing but V1 by I1. So if we apply the KCL at node C, that is minus I1 plus 2V1 plus V1 divided by 2 ohms equals to 0. This is the parallel combination of this is nothing but a 1 ohm. So I1 equals to 2 plus 1 by 2. This is V1. Here V1 by I1 is nothing but 5 by 2 V1. That is 2 by 5.4 ohms. Hence option D is correct.
Operating torque equation, okay, he represented it as T is equal to K1 I square minus K2 into V square. See here, he has given this torque equation. Okay, now there are different types of relays we have in power system network for protection of the transmission and distribution equipments, even generation equipments. Okay, now if you see here, he has given 4 options and each relay will have different actuating quantities. Actuating quantities can be of anything, okay, reactance, current, voltage. Okay, now this torque equation represents, okay, this is the torque equation for impedance relay. Option is C. Following statements regarding bundle conductors. What is bundle conductors here? Bundle conductors means there is more than one subconductor per phase. Okay, let us take this as a bundle conductors, R phase, Y phase and B phase. If you see here, R, Y, B phases, each phase has more than one subconductor per phase. That is called bundle conductors. Now, when you have bundle conductors, what happens regarding self GMD, mutual GMD and inductance? This is what the question he has asked. Okay, now if you see here, mutual GMD means distance between phases. Okay, mutual GMD remains same. Mutual GMD remains same because distance between phases is not changed. Okay, now if you see, if you have only one subconductor per phase, now what is GMR for this one? GMR is equal to R dash. If you have more than one subconductor per phase, GMR concept is not valid. Okay, so self GMD concept is valid. Now what is self GMD here? Self GMD is given as square root of R dash into S, where S is distance between two subconductors. Okay, if you see here, self GMD, earlier it is GMR is equal to R dash, now it is R dash into S, where S definitely will be greater than that of R dash. What does it mean that self GMD is increasing? You can say self GMD as GMR also if you speak in power systems point of view, whereas in mathematics point of view it is not valid. Okay, but self GMD in many textbooks in power systems they will refer as GMR, geometric mean radius. Okay, that means if you see GMR compared to one subconductor per phase, it is increasing. Okay, now if you look at the options there, mutual GMD is approximately same as normal conductor. So first option is correct one. Self GMD decreases compared to normal conductors. This option is wrong. Okay, because self GMD is increasing. Now, what is the third one he has given? Inductance decreases compared to normal conductors. Now, what is inductance equation? L is equal to 0.2 log GMD by self GMD into millihenry per kilometer is the unit. Okay, if you see here GMR remains same, self GMD is increasing. What does it mean that inductance decreases? So third one is also correct. So which of the following statements are correct is 1 and 3 are correct. So option B is the right answer. Type insulators having 4 discs and is equipped with static shielding method. Okay, then which of the following statement is correct? Okay, if you see here static shielding method, let us take this is as a tower. Okay, a tower having 4 discs, capacitor 1, that is nothing but disk 2, disk 3 and disk 4. Since tower will act as a body, so there will be shunt capacitance formation between tower body and insulator pin. Okay, now this is conductor which is carrying rated voltage V per phase. Okay, now if you see here, what is static shielding method? Static shielding method is there will be a tip of the conductor which will be opposite to that of tower body. Okay, now if current I is flowing in this way, there will be small leakage current here. Let us take current flowing to this one is I1 and this will be I1 dash. Similarly, current flowing through this is I2 and the leakage current is I2 dash. Okay, current flowing through this one is, let us take it as I3 and this one as I3 dash. Now what happens in static shielding method is we are taking part of the AC SR conductor in this manner, just opposite to that of tower body. Okay, what we are doing by making this one is there will be a shunt capacitance formation between pin and this conductor. Okay, now leakage current in this case, let us take it as I1 double dash. Similarly here leakage current is I2 double dash. Similarly here leakage current is I3 double dash. Now what we will do here in static shielding method is leakage currents between insulator pin and tower body, that is I1 dash, which is equal to capacitance formation between insulator pin and this tip of ACSR conductor. Okay, that is I1 double dash. Similarly I2 double dash is equal to I2 dash. I3 dash is equal to I3 double dash. What happens if you maintain this charging currents equal is voltage across discs is same, or you can say voltage is same for all discs. We can make string efficiency as 100% by making use of static shielding method. Okay, so option C is correct answer.